dividing polynomials. And so it kind of takes you back to third grade to long division. It's the same type of process as long division, only we're going to use it with equations. So first of all, we're going to just practice long division like we did in grade school. So first of all, come over to the side, and we want to write 687 divided by 5. Okay? So we want to go through the process of that. So again, first thing we do on long division, just to refresh your memories. So how many times is 5 going to 6? 1, right? So we put a 1 up at the top, and 1 times 5 is 5. So then what do we do now? Right, subtract, right? So 6 minus 5 is 1. Then what do we do? Bring down the 8. And then we see how many times does 5 go into 18, which is 3, right? And then we multiply. So 3 times 5 is 15. Then we subtract, right? So 18 minus 15 is 3. Then we bring down the 7, right? How many times is 5 going to 37? 7. So 7 times 5 is 35. And then we subtract. And 37 minus 35 is 2. So if we take you back to third grade before you discovered decimals, right, we would be finished, right? So the answer would be 687 divided by 5 is 137 with a remainder of 2. Okay, let's bring back some good memories. Okay, so the reason why I did that is because a lot of the same processes, like bringing down the next number and subtracting, are part of the process we're going to do with polynomials. Okay, and that's part of the steps that people tend to forget. So this process is very similar to what we're going to do with equations. Okay, now one more thing. What if I had done, let's say I did 125 divided by 5. Okay, and the answer to that is 25. Remainder of 0. Okay, what does that remainder of 0 tell me about 5 and 125? It goes in evenly. What else? 125 is divisible by 5. What's the F word? The good F word that it tells me. What's the bad one? What's the F word we love in the algebra too? Factor, right? So it actually tells me that 5 is a factor of 125, right? And that 25 is also a factor of 125. Does that make sense? So with polynomials, it means the same thing also. It tells us whether it's a factor or not. Okay? So this first little slide is just from the book, and it just it goes through numerical long division and polynomial long division. So we're going to go through this a little bit ourselves. This little statement is a little bit early, but it says equations must be in standard form with 0 coefficients if needed. What that means is when we set up our problems, you want them in standard form, and if there's any degrees that are missing, you want to fill them in with zeros. Okay, it doesn't really apply to this problem. It will in a little while. Okay, but just keep that in mind. I'll talk about it when it actually happens. Okay, so first let's start. So we're going to say 4x squared plus 23x minus 16 divided by x plus 5. So our divisor is x plus 5. So we're going to set it up x plus 5. And then our division symbol. And then inside of the division symbol is 4x squared plus 23x minus 16. Now we're going to learn 2 ways to divide today. Long division is first, and it's kind of the yucky way. And then we're going to learn a really simpler way that you can use most of the time. Okay? Okay, so questions about this? Okay. All right, so now the first thing we're going to do, and normally in long division we would say how many times does this go into this, right? But that's kind of a weird way to look at it, and it's hard to answer it that way. So the question we really want to say is, what do we have to do to this x, okay, to make it equal to 4x squared? what could we multiply x by to make it equal to 4x squared? 4 times x, right? Because x times 4x would give us 4x squared. So we want to multiply all of this by 4x, and since it's 4x to the first, we're going to place that above the x to the first right here. Okay? So whatever term you're putting up on this top line, you want to kind of keep your columns straight about the degree. All right? What's that? Oh, that's x to the first. Okay? All right, so now, just like in long division with numbers, we multiply this 4x by x plus 5, but we have to distribute, right? So 4x times x gives us 4x squared. 4x times 5 gives us plus 20. Okay? And now what do we do? In regular long division, what do we do now? Subtract, right? And that's the tricky part here. We want to subtract, so you want to make sure you subtract both terms, so you really want to always draw the subtraction in parentheses, okay, to kind of remind you that you're distributing.
Shouldn't it be 20x?
Oh, yes, thank you. Yeah, 20x.
Where are you getting the 20?
Okay, so I chose 4x, right, because I needed to get this x to equal this first term, right? So when I chose this 4x, I am distributing this to x plus 5. So 4x times x is 4x squared. 4x times 5 is 20x. Okay? Now I'm subtracting. So 4x squared minus 4x squared is 0. 23x minus 20x is 3x. Okay? Now, what do I do next in normal division? What would I do? Bring down the next term. So I bring down the negative 16. Okay? Now I want to see what would I have to multiply this x by to make it 3x. 3, right? So I place the positive 3 up here. And again, the columns are matching up. I'm putting this constant over a constant. And now I multiply x plus 5 times 3, but I have to distribute, right? So 3 times x is 3x. And 3 times positive 5 is 15. And then I subtract, right? So just be sure you subtract all of it. So 3x minus 3x is 0. Negative 16 minus 15 is what? Negative 31. Okay. Now, is there anything I can do to this x to make it equal to negative 31? No, right? So I'm finished. That's my remainder. The official way to think about it is that now this degree x is greater than negative 31, the degree of that, so I can't go any further. Okay? So the answer to 4x squared plus 23x minus 16 divided by x plus 5, the answer is 4x plus 3 with the remainder of negative 31. Okay? Questions about it? A little strange for a process. Very good. All right, so let's try another one. Okay. So now we have 3x to the 4th, etc., divided by x squared plus 1. So this is one where, again, you want to make sure, because it's so important for the columns to line up, right, for every degree, and you want to make sure you're not missing a degree. In this equation, though, are we missing one? We have an x to the 4th, x to the 3rd, x to the 2nd, but we don't have a x to the 1st, right? So when we write this out in our problem, we're going to want to add a 0x in there to keep because our answer may have an x to the first term. Same thing over here, on x squared plus 1, are we missing a term? X to the 2nd, do we have an x to the 1st? No, so we're missing it, so we're going to have to add one there also. Okay? So when we set up our problem, we're going to say x squared plus 0x plus 1 divided by, I'm sorry, we're dividing 3x to the 4th minus 4x to the 3rd plus 12x squared plus 0x plus 56 divided by x squared plus 0. Okay? Very good. All right, so now, to start this, we first say, what do we have to multiply x squared by to make it equal to 3x to the 4th? So raise your hand about that. Taylor? 3x squared. Does everybody agree with that? So again, since it's 3x squared, we're going to start our answer at the x squared place. So we're going to put 3x squared right there. Okay? And now we distribute that 3x squared to this whole equation. So 3x squared times x squared gives us 3x to the 4th. 3x squared times 0x gives us 0x to the 3rd. And on that one, it really just gives you 0. Okay? I mean, when we add it, it's just going to be adding 0. But I think sometimes it's helpful to keep the x's in there. 3x squared plus 1 is 3x squared. Okay? And now we're going to subtract. So 3x to the 4th minus 3x to the 4th is 0. Negative 4x to the 3rd minus 0 is going to give us negative 4x to the 3rd. 12x squared minus 3x squared gives us positive 9x squared. Okay, bear with me. All right, and now, oops. Anyway, okay, so now the question is, what do we multiply x squared by to get negative 4x to the 3rd? Anybody? Negative 4x, right? Because we have to introduce a negative 4 and we need one more x. So negative 4x. Okay. So now we're going to distribute that negative 4x. So negative 4x times x to the 2nd gives us negative 4x to the 3rd. Negative 4x times 0x gives us negative 0x squared. And negative 4x times 1 gives, gives negative 4x. What did we forget? We needed to bring down that 0x. Make sense? So now we're going to subtract. So negative 4x to the 3rd minus negative 4x to the 3rd makes it plus, right? So that cancels out. 9x squared minus a negative 0 gives us 9x squared. 0x minus a negative 4x gives us positive 4x, right? Okay. Now what's next that we forgot last time? Bring down the 6. Okay, so what do we have? So what can we multiply x squared by to make it 9x squared? 9, right? So again, we're going to write a 9 up here, and it should be over the constant term, which it is. It's over 56. So now we distribute that 9. So 9 times x squared gives us 9x squared. 9 times 0x gives us 0x. 9 times 1 gives us 9. Now we subtract. So 9x squared minus 9x squared is 0. 4x minus 0x is 4x. 56 minus 9 is what? 47. Positive 47. Now, is there anything we can multiply x squared by to get 4x? No, right? Or you can think about it as this degree is now higher than our problem, so we're finished. So the answer to this is 3x squared minus 4x plus 9 with a remainder of 4x plus 47. Okay. Questions about that? Very good. That's done yet? Gets easier. We're going to do one more horrible problem, and then it gets better. I promise. Okay. So now, this one is an example of, again, missing terms, right? What, if we're going to divide x to the 5th minus 32 divided by x minus 2, what terms are we missing from that problem? X to the 4th, x to the 3rd, x to the 2nd, right? So when we set this up, we're going to, inside the division sign, we're going to say x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x to the 2nd plus 0x minus 32. Okay, because again, we have to allow for those degrees because our answer might need those. You will never get one of those. Okay. All right, and then we're dividing by x minus 2. So x minus 2 itself is not missing anything, so we're good on that one. Okay. All right, so now let's get started. So what do we have to multiply x by to make it x to the 5th? X to the 4th, right? So we can put it right there, right above x to the 4th. So we distribute x to the 4th times x is x to the 5th. X to the 4th times negative 2 is negative 2 x to the 4th. Right? We subtract. So x to the 5th minus x to the 5th is 0. And then 0 minus a negative 2x to the 4th gives us what? Positive 2x to the 4th, right? And then we bring down our x to the 3rd. Now, what do we have to multiply x by to make it 2x to the 4th? 2x to the 3rd, right? Then we distribute 2x to the 3rd times x gives us 2x to the 4th. 2x to the 3rd times negative 2 gives us negative 4x to the 3rd. And then we subtract. So 2x to the 4th minus 2x to the 4th cancels out. 0x to the 3rd minus a negative 4x to the 3rd gives us a positive 4x to the 3rd. And we bring down our x to the 2nd. Now, what do we multiply x by to make it 4x to the 3rd? 4x squared, right? And then we distribute, so we get 4x to the 3rd minus 8x squared. Then we subtract. 4x to the 3rds cancel out, and we get 0 minus a negative 8 gives us positive 8x squared. And then we bring down 0x, right? Almost done. And what do we multiply x by to get 8x squared? 8x. So 8x times x gives us 8x squared. And 8x times negative 2 gives us negative 16x. So then we subtract. And we get positive 16x minus 32. We bring down our negative 32. This is the exciting part. There's one. What do we multiply x by to get 16x? 16. So we put a 16 up here, and 16 times x is 16x. 16 times negative 2 is negative 32, right? Then when we subtract it, 16x minus 16x is 0. Negative 32 minus the negative 32 is 0. So we get 0. So what this tells us is x minus 2 a factor of x to the 5th minus 32? Yes. So we're going to go into a little bit of pre-cal here. A little preview of next year for you guys. So x minus 2 is a factor. So what's the root of x to the 5th minus 32? What would be a root from that? From 2, right? Because if you take the factor, set it equal to 0. So now, just from this equation, we know that x minus 2 is a factor of this function. 2 is a root, right? So if we wanted to get really, and I'm going a little bit overboard here, so you all don't, this won't be on the test. But I just want to show you how this all relates, because we'll do it next year. So we know that this function is crossing at 2, right? What about the end behavior of this function? X to the 5th, what's the end behavior look like?
Down up.
Down, up. So even just from this one equation, we can sketch a rough graph that looks like that somehow. I mean, it may look different in the middle, but we know it's crossing at 2 because it's a factor and a root, and we know it's going down up on the ends. Isn't that fascinating? Okay. All right, so this is long division. And yeah, it's long, right? It's kind of a pain. There's a lot to remember, a lot to mess up, especially like the division, like distributing, dividing, subtracting, all that kind of stuff, okay? You have to use long division anytime you're dividing by x squared or above, okay? We have a shortcut version called synthetic division that you can use when you're dividing by a linear expression. So who can give me an example of a linear expression? Is x squared minus 7 a linear expression? No. Is 14x to the 3rd minus 2x squared plus x a linear expression? No. What's a linear expression? X to the 1st, right? Y'all are dead down out there. So like x minus 4 is a linear expression, right? That was just on your test. X plus 3 is a linear expression. So this shortcut method we're going to use can be, you can use it and you want to use it anytime you're dividing by something that's got x to the 1st in it and nothing higher, okay? Okay. Okay, so what we're going to do is synthetic division. And this first slide is just all the words that explain it. I'm not going to read through it because it's kind of confusing until you see an example of it. But here are the steps if you're like home doing your homework and you forgot how to start. This is the steps. So we're just going to do some examples. Okay? And it's much easier, but it's kind of different. So you want to do exactly as I say to set it up. And it's worth it because it's very easy, very much easier than what we did. All right, so again, we're still going to divide this polynomial by x minus 4, okay? So first thing you want, and as we set this up, you'll notice we're not going to have any x's in our actual problem. We're just going to be dealing with numbers. So we start with an x minus 4. So if x minus 4 is the factor, what's the root that goes along with that factor? 4, right? So we're going to take 4 and put it in a box. So you can think about it in a couple different ways. You can either think about it as always just putting in the opposite of what it says. So if it says x minus 4, you put in a positive 4, okay? The technical way to think about it is if we're dividing by this factor, we're actually going to be dividing by the root that goes along with that, okay? All right. Now, next thing we're going to do is we're going to line up these coefficients from our given equation, okay? Now, on synthetic division, you also want to always check that you're not missing any, just like we did on long division. missing any terms, but we're not here because we have 3, 2, 1, 0. So we're not missing anything on this one. So we go ahead and line those up. 2, -3, -18, -8. Right, it's the same line as before. Okay. Now you want to skip a line because we're going to write stuff here and draw a total line. Okay, everybody good? All right, so now to begin with, first thing we're going to do is we're going to draw an arrow and just bring down that 2. And it's actually really, a lot of girls skip stuff just because they don't like to write too much. But you really want to always draw that arrow and bring down 2 because it's kind of a reminder that you're not going to put any number here, okay? And you'll see why in a second. But, so it's good practice just to always start with this so you know that that spot stays blank, okay? All right, now when we get into the method, I'm going to draw these little dots that I would recommend you not drawing, but it helps me show you all the pattern, okay? Because what we're going to do first now is we're going to multiply 4 times 2. So what is 4 times 2? 8, right? That's not a trick question. Okay, so 4 times 2 is 8. So we're going to multiply this and put the answer right there. So we're kind of making a little check mark. I mean, you can if you want to, but I think they're kind of annoying. I'm doing them more just to show. I mean, they're not actually part of the problem. They're just me showing you how to do it. So 4 times 2 is 8, and then we add this column. So we add down. So -3 plus 8 is what? 5, right? Just write 5. But you're adding that column. Okay? Now we're going to multiply again. We're going to multiply 4 times 5, which is 20. So we're making, again, another little check mark. And then we're going to add that column. So -18 plus 20 is 2. Then we're going to multiply again, make a little wider of a check mark. So 4 times 2 is 8. So we put it up here. And then we add down. So -8 plus 8 is 0. Tia, you got a question?
No, they're right. So it looks like it says -5, but it's not.
Oh, yeah.
Just looks.
No, that's good. Let me. Yeah, fine. Okay.
Will there be negative numbers?
Yeah, there could be, and we'll see some, as you add. Okay. All right. So now that's the process. We're done. Okay. The numbers down here represent the coefficients of our answer. Okay. So we started with an x to the third equation. We divided by x to the first. So our answer is always going to be 1 degree less than what you started with. Okay? So what is 1 degree less than 30? 2. So this 2 right here represents the coefficient that goes with x squared. Okay? If we had started with like an x to the 7th, let's say, then this would have been 2x to the 6th. Okay? It's always 1 less. And then we just go down from there. So this represents the highest term of our answer. So this is 2x to the 2nd. So then the 5 goes with goes with x to the 1st. And then the 2 goes with x to the 0, or the constant. Okay? So you always use the first one as 1 less than what you started with, and then assign them in order. And you should always have a column left over, right, which represents your remainder. So if something happens you don't have a column left over, then it means you missed a column when you started. Okay? Okay? So the answer to this division is 2x squared plus 5x plus 2, remainder is 0. So is x minus 4 a factor of this equation? Yes, right? Because it's got a remainder of 0. Okay? So much easier than long division, right? It's just kind of quirky. Just a lot to remember. All right, so let's try another. Okay? So again, we've got 9x squared minus 21x minus 20 divided by x minus 1. So in our box, we're going to put what? Positive 1, right? And then we want to check and make sure we're not missing any terms. So we're starting with x to the second, x to the first, and constant, so we're not missing anything. So we line up 9, negative 21, negative 20. We draw the line and draw the arrow. Okay, everybody good? So now we bring down the 9. So 1 times 9 is 9, right? Then we add down. So negative 21 plus 9 is what? Negative 12. So someone had asked about, will we ever have a negative there? And yeah, you can. Right? Now we multiply 1 times negative 12, and we get negative 12. And we add down. So negative 20 plus negative 12 is negative 32. Okay? So now we're done, and now we write out our answer. So if we started with an x to the second, what's our answer going to start with? X to the first, right? So we get 9x minus 12. So we've just got two terms, right? Which is fine. We've got a column left over. So that is our remainder. So is x minus 1 a factor of 9x squared? No. Right?
You have to like write that down on the test, or is that kind of given?
It's given. Well, yeah, you'll see what we're going to do with that now. Okay? Everybody good? All right. Okay, let's try another one. Okay, so now this next one talks about just what Megan was saying. What do you do with that information? Like, is it that important? Well, it is now, because what we're going to do is use synthetic division to completely factor polynomials. And the last two questions on your homework, 29 and 30, will ask you to do this. So what we're going to do here is we're going to divide, and this is going to be a factor. So we expect a remainder of 0, right? And then we're going to look at our answer and see if we can factor it further to find more roots or more factors. Okay? So let's try this. So what do we put in our box? If we're divided by x plus 5, then we put a negative 5. It's always the opposite. Or you think of it as the root that goes along with it. Now, this is 1x, or x to the third, so what coefficient do we put down? 1, right, for this one? So 1, 3, negative 13, negative 15. Draw the line and bring it down. And I want you guys to try that. Try to finish that up. Okay, so you bring down the 1 times negative 5 is negative 5, 3 plus a negative 5, negative 2, negative 5 times negative 2, positive 10, negative 13 plus 10, negative 3, negative 5 times negative 3, positive 15, so 0. So our answer equation is 1x squared, so you don't have to put the 1. We had an x to the third to start out with, so 1x squared minus 2x minus 3 with the remainder of 0. So is x plus 5 a factor? Yes, right? But how many factors, so we know x plus 5 is a factor, how many factors do we expect this equation to have? How many roots do we expect it to have? That was the bonus question on the test, right? So 3, right? So we've got 1, so we expect 2 more. But now we've simplified this equation down to this, right? Which is a quadratic trinomial, right? So can we factor this? Yes, how do we factor it? What's that?
So I do not remember.
Okay, how do we...
0x.
What's that?
0x.
0x, no.
Do you do the magic question?
Magic question, right? It's 3 terms, it's a quadratic. There's no, or a is 1, right? So what is the magic question? What multiplies to -3 adds to -2? So what multiplies to -3 adds to -2? -3 and +1. Okay. So our factors are x plus 5, x minus 3, and x plus 1. So you can only do this if you have a remainder of 0, right? Otherwise, the answer equation really has nothing to do with the original equation, or you don't want to keep going. And for homework and quiz purposes, you only need to do this when it's never wrong. Anytime you get a remainder of 0, if you can factor the answer, that's fine. But you only really have to, on questions 29 and 30, will tell you to do that. And on the quiz, I will tell you when you need to go ahead and factor, okay? So we've gotten these 3 factors. So if we wanted to talk about, and I won't go into the graph here, but if we want to talk about the roots of this equation, what are they? -5, 3, and -1. So a little bit of pre-count there for you. Okay? All right, now, next one we're going to do, I want to show you how simple this process is compared to long division. So this is x to the 5th minus 1 divided by x minus 1. So this problem is very similar to the last one we did, this real ugly one that took us forever, right, on long division. Well, this one's kind of a fun one, if you will. You may not think so, but it's kind of fun. And very simple to do since I division-wise, okay? So let's try. So what did we set up in our box? If it's x minus 1, we set up with plus 1. So we've got x to the 5th, so that's got a coefficient of 1, right? But how many do we need to fill in now? Because we need to fill in x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, minus 1. Okay, then we draw the line, draw the arrow, bring down the 1. Okay, now this is the one that's kind of fun. So what's 1 times 1? 1 times 1 is 1. What's 0 plus 1? What's 1 times 1? What's 0 plus 1? 1. What's 1 times 1? 0 plus 1. 1 times 1. 0 plus 1. 1 times 1. -1 plus 1. 0. Okay, so now we're done, right? So now what is our first term going to be? X to the 4th, right? We started with x to the 5th, so x to the 4th. So the coefficient is 1, so you don't have to write the 1, but you can. So we got 1x to the 4th plus 1x to the 3rd plus 1x squared plus 1x plus 1, remainder of 0. So much, much easier than the last one we did on real division, right, or long division. So is x minus 1 a factor of x to the 5th minus 1? Yeah. But we're left with an x to the 4th equation, so we really don't have a way to keep going on this one. I mean, you will in pre-cal next year. You'll know how to keep going. But for now, all we know is we found one factor, and we don't really know how to find the rest of them. Okay? Very good? All right. And last one we're going to do in our notes is this one. And I just want to show you, because the shortcut to what you put in the box doesn't really apply when it looks like this, 2x minus 1, right? Because you wouldn't want to ignore that 2 and just put a positive 1 in the box. But what is the root that goes along with this? If we took 2x minus 1, set it equal to 0, and solved, it's 1/2, right? I think somebody said that. Okay. So in this case, we want to put 1/2 in the box. We even could do fractions. Yay. And now we line up the coefficients. Are we missing anything? 4, 3, 2, 1. So line those up, and then I want you guys to go ahead and try this one. Because even though it's a fraction, It's kind of an easy fraction to multiply by. So go ahead. Okay. So we bring down our 2. 1/2 times 2 is 1. 3 plus 1, Megan, is 4. 1/2 times 4 is 2. -4 plus 2 is 2. 1/2, what feels quiet? 1/2 times -2 is 1. 1 minus 1, 0. 1/2 times 0, 0. 1 plus 0 is 1. Okay, so now if we build our answer, what's our first term? 2x to the third, right? 2x to the third plus 4x squared minus 2x plus 0, or you don't have to write that 0, but if you do want it to account, like this in your head, at least make sure you're like, okay, that's the constant, and I have a column left over for the remainder. So is 2x minus 1 a factor of this equation? No. So that's all you can do. Okay? All right, get some whiteboards. You can just do a couple problems before you do homework. That's fun.
Yes.